All right, so like I was saying before, the concept of Pythagorean theorem, it all relates back to just right triangles, only right triangles. And if it is a right triangle, it must satisfy the Pythagorean theorem formula. If it is not a right triangle, it will not satisfy the formula for the Pythagorean theorem. So what Pythagorean theorem does is it describes a relationship that exists between the legs of the triangle and the hypotenuse of a triangle. That's a tricky word. Just make sure that you understand what it is. The hypotenuse, which we label the value C, is always going to be directly across from wherever your right angle is. And it is also going to be the largest measurement within your triangle. So it is this measurement located right here. You have a 90-degree angle that is formed. Directly across from that 90-degree angle is the hypotenuse. And again, we label that value C. The legs are the other two measurements, and they're going to form your right angle. And we call those legs A and B. They are going to form the right angle. So this is leg A and leg B. It does not matter which one you label A and which one you label B. It's perfectly fine if you always want to label the missing leg A or the missing leg B. Again, it does not matter. But what's important to know is that they are going to form the right angle. The legs form the right angle. The hypotenuse is directly across from the right angle. And basically what it means is if you take the measurement of leg A and you square it, and you take the measurement of leg B and square that, and then add those two squared values together, it should be the same thing as taking the value of C, the hypotenuse, and squaring it. And again, when you're just given number measurements, the hypotenuse is always going to be your largest measurement, always the longest side. So if we're taking a look at this problem right here, we have a right triangle, and it has leg measurements of 12 and 9. I know that these are my legs because they are what's forming my right angle. Okay, when I piece those together, they form a right angle. So those are going to be my leg measurements. Again, it does not matter which one you label A and which one you label B. I'll go ahead and just call the 12 A and the 9 can be B. And that means C, the hypotenuse, is the value that happens to be missing. But the question that it's asking is not for the measurement of C, it wants the perimeter of the triangle. So the perimeter of the triangle means that we need to know all three measurements so that we can add all three measurements together. We can't figure out the perimeter until we find that last measurement, that measurement of C. So what we're going to do first is we're going to plug them into our formula. I know that A is going to be equivalent to 12, and that B is going to be equivalent to 9, and that C is an unknown value. So I'm going to put a question mark. When I plug it into my formula of A squared plus B squared, that means I need to do 12 squared plus 9 squared. 12 squared plus 9 squared is what I'm going to need to do first. All right, so we have 12 squared plus 9 squared, and then that's going to be set equal to C squared, which we don't know, so we're just going to leave it as C squared. So now we just need to go ahead and do these values. Again, these are things that you should have perfectly memorized at this point. What is 12 squared, guys? 144. What is 9 squared? 81. So when we piece those together, we've got 144 plus the 81 is supposed to be equal to C squared. When I add 144 plus 81, what do I get? 225. So we now have 225 is equal to c squared. Who can raise their hand and remind me, because we just did this in the last unit, what is the inverse operation of a power? Bridget? A root, right? Any power, the inverse operation of any power is a root. In this case, because the power is squared, the inverse would be the square root. So go ahead and make sure you write that down as a reminder, a nice little star here, that the square root is the inverse of a square power. The square root will be the inverse of a squared power. So in order to get c isolated, I would have to take the square root of c squared, and that's going to leave me with just c. But if I do that to one side, I must do it to the other side. So I must take the square root of 225. And what is the square root of 225? 15. And we're only going to be dealing with positive values because we're dealing with geometry, measurements. Measurements come in positives. So we have c is equal to 15. That's part of our answer. We now know what the value of c is going to be, but remember what the question was asking. The question was asking for perimeter. So that's where we have to now incorporate the value of c. To find the perimeter, we're just going to add all the values together. Perimeter is just the sum of all the measurements. So we're going to take the value of a, add it with the value of b, and add it with the value of c. So we take 12 plus 9 plus the 15 that we just solved for. What do we get? 36. So our perimeter is going to equal 36 inches. We're talking about inches. Okay? So you're utilizing Pythagorean theorem to solve for a missing value, and then once you've got that missing value, you're answering any additional questions, whether it's asking for perimeter. It might be asking for area, like this next question is. Now, depending on what's missing will determine how you solve it. You are not always going to be squaring and then adding and then square rooting. You only do that if the value of c is missing. When a leg is missing, you're doing it a little bit different. Okay, so let's take a look at problem 2. Problem 2, one of the legs happens to be missing, right? We've got these two lines that are creating or forming that right angle, and directly across from it is going to be our value of c, our hypotenuse. So in a situation like this, when we set it up, we don't know what the value of a is going to be. That's missing. We do know that the value of b is equal to 3, and we happen to know that the hypotenuse c is equal to 5. So then we, again, just plug it into our Pythagorean theorem formula. We have a squared plus b squared is equal to c squared. But in this case, a squared is an unknown value. B squared now becomes 3 squared. C squared now becomes 5 squared. What's 3 squared? 9. What's 5 squared? 25. So this is a different setup. What do we need to do now? Alex? Minus the 9 from 25. You need to subtract the 9 from both sides because you've got to get that a squared isolated so that you can then take the square root. So the inverse operation that we need to perform first would be to subtract 9 from both sides. That leaves us with a squared now equaling 16. Then we can go ahead and do that inverse operation. We can take the square root of both sides to get A by itself. And A is going to be equal to what? To 4. Okay, so we now know what A is going to be equal to. From there, we then need to plug it into our formula because we want to know what is the area. So for area, to find the area of a triangle, you're going to do what? Nicholas? 1/2 times the base times the height. The base and the height of a right triangle are the legs. Write that down. Base and height of a right triangle are the legs, A and B. Your measurements A and B are going to be the measurements of your height and your base for your right triangle. Those legs form your height and your base. So when we're performing our formula, all we're going to do is take 1/2 of the base times the height, which happens to be your leg A and your leg B. So we can say that this is the base and that this is the height. Excuse me. So here we're just going to do 1/2 of the value of A, which is 4, times the value of B, which is 3. 4 times 3 is what? 12. And then half of 12 is 6. So the area is going to be equal to 6 units squared. If they don't give me a measurement like inches or yards or feet or millimeters, you just put units. You just say units squared. Okay, any questions so far? Pretty simple compared to the last unit? Yeah. Like I said, last unit is probably as difficult as it's going to get until we get to systems, which is the very last thing of the school year. Systems can be pretty difficult too, and bivariate data, but those are at the very, very end. You guys got the most difficult, I think, out of the way. So this is a nice, easy unit. Okay? All right, go ahead and flip it on over to the back. Anybody still need this? Raise your hand if you still need this. Okay, we'll wait for a second, Ray. All right, let's go on over to the back. So if your hypotenuse, I'm just giving you guys the breakdown of what to do. If your hypotenuse, if the value C happens to be missing, then these are the steps that you're going to perform. You're going to first take the square of your A squared and B squared, all right? You're going to square, then you're going to add, and then you're going to square root. Those are your steps if your hypotenuse is missing. You square, you add, you square root. What it means is that you do A squared and you do B squared. Then you add those two squared answers together, and then you take the square root of that sum. That's all that you're doing. Square, add, square root. If it happens to be that your legs are missing, one of the legs happens to missing, you square, subtract, square root. You would square, subtract, and square root. You would take A squared and C squared, or you would take B squared and C squared, depending on which leg you label it as. But you would take the leg, square it, you would take the hypotenuse, square it. Then you would find the difference between the two values. You would find the difference between the two values and then take the square root of that difference. Alex? Nope, you cannot do that. Let me show you why. So that's a good question to ask. Let's say that we are dealing with, well, here, we'll deal with the last one that we just had. If you were to say, hey, I've got my triangle, and I know that this measurement is 4 and this measurement is 5, and I want to find out what this measurement is, you're saying instead to just do 5 minus 4 and then square that answer, right? What's 5 minus 4? 1. And then 1 squared would just be 1. But that's not going to be the value here, because you would need to be doing 5 squared minus 4 squared and then take the square root of that. 5 squared is 25 and 4 squared is 16. When you subtract those, you'd get 9, and the square root is 3. Very different answers. So you have to make sure that you follow that process. You must square it first before you do any additions or subtractions. Okay? All right. It's a good question, a very valid question. All right. I want you guys to go ahead and do problems 3 and 4 on your own. You're just solving for the missing value, whether it's a hypotenuse or a leg. All right, let's go ahead and go through this. Who can tell me what value is missing? Is it a leg or a hypotenuse? Bridget? Hypotenuse. And who can tell me what they got for the value of the hypotenuse? Yuchan? 25. Very good. So we know that these values are our legs. They form the right angle here. They're going to form that right angle. So this is a value of A. This could be the value of B. Again, if we're doing A squared plus the B squared, that needs to be set equal to C squared. That means we're going to replace the A with a 15. So we're going to do 15 squared. We're going to replace B with a 20, so we're going to do 20 squared, and that's going to be equivalent to our value of C squared. 15 squared is 225. 20 squared is going to be 400, and when we combine those two together, that's 625, and then you just need to take the square root. So take the square root of both sides, and you'll get your value of C, and C is going to be equal to 25 millimeters. Don't forget to put your unit of measurement. 25 millimeters. Okay, for problem 4, do we have a hypotenuse or a leg missing? Trang? A leg, okay? And what is the value of the missing leg, Maya? 15, very good. So again, it doesn't matter whether we label the leg A or B. I'm just going to go ahead and label it A, label this one B. The 17 is going to be the C. Again, this is what's forming our right angle here. So those are creating those leg measurements. So we're going to have A squared plus 8 squared is equal to 17 squared. 8 squared is going to give us 64. 17 squared is going to give us 289. Then we're just going to subtract 64 from both sides. By doing so, that gives us A squared is now equal to 225. Then we take the square root. Okay, and that's going to give us A equaling 15, and that is yards. Okay. So now we get down here to the bottom where we're trying to identify whether the measurements are going to create a right triangle or not. So if they create a right triangle, then they will satisfy the Pythagorean theorem formula. If they don't form a right triangle, it won't satisfy it. And remember, I told you it's really important that the hypotenuse is always what kind of measurement? Huh? It's not an even. Look back at your notes. It's always going to be the what, Dylan? The biggest. Your hypotenuse is always going to be your largest, your longest, your biggest measurement. So when you're looking at these, they're not put in any particular order. They're not ordered from least to greatest. You need to identify which one is going to be the hypotenuse by looking and seeing which one's the largest measurement. Which one's the largest measurement for problem 1? 30. So this is our value of C. 30 is going to be our value of C. It does not matter which one of these is A and which one is B. I'm just going to go ahead and put 18 as A. and 24 as the b. And then you just plug it into your formula and see if it works or doesn't work. So that means we're going to do 18 squared plus 24 squared, and that should be equal to 30 squared if it is a right triangle. What is 18 squared? Come on, guys. Who's got it memorized? Divya? 324. What is 24 squared? Bridget? 576. See, this is why it's helpful when you have those perfect squares memorized. 30 squared. Anybody know what 30 is? That should be an easy one. Alex? 900. Okay? So now we're just going to add 324 and 576. When we add those together, it comes out to 900. So 900 is equal to 900. That is a true statement. So yes, this is a right triangle. If it does not come out to a true statement, so when you combine those squared values, if it does not equal the same thing as what your hypotenuse squared is, then it's not a right triangle. Go ahead and do problems 2, 3, and 4 on your own. For problem number 2, guys, is it going to form a triangle, or right triangle, yes or no? No. Okay, our largest measurement happens to be the 7. That's going to be the C. The other two values are going to be our A and our B. So we can do 4 squared plus 5 squared is equal to 7 squared. 4 squared is going to give us 16. 5 squared is going to give us 25. 7 squared is going to give us 49. When we add 16 and 25 together, that's going to give us 41, which is not equal. This is not equal to 49. Not equal, so I'm going to put a little slash through it. So this is not going to form a right triangle. Okay, let's take a look at problem number 3. Right triangle, yes or no? No. Okay, 24 happens to be the largest one. That's our C. The other two values are our A and our B. We're going to do 10 squared plus 15 squared, and that needs to be set equal to 24 squared. 10 squared is 100. 15 squared is 225. 24 squared is 576. When we add 100 and 225 together, we get 325, which is not equal to 576. So no, this is not a right triangle. What about problem number 4? Right triangle, yes or no? Yes. Okay, 8 and 15 are our A and B, so we have 8 squared plus 15 squared. 17 is our largest, that's our C, so we have 17 squared. 8 squared is going to be 64. 15 squared is 225. 17 squared is going to be 289. And when we add those together, we get 289. So 289 does equal 289. Yes, it is a right triangle. Okay, you guys have a quizzes, 20 questions on Pythagorean theorem. It's loaded into Google Classroom right now. You get one attempt only. Please remember that your login for quizzes, it is your first name, then the number 1 at gcpsk12.org. Password is lions22. Guys, you really should program it to save your login, to remember it, so that way you don't have to sit here and remember it anymore. You should save it into your computer.